Our universe is a vast and mysterious place. It is filled with billions upon billions of galaxies, each a swirling island of stars, gas, and dust. Some galaxies exist in relative isolation, like solitary wanderers in the cosmic darkness. Others, however, are drawn together by gravity's invisible hand, forming immense structures known as galaxy clusters. Among these cosmic metropolises is the Hercules cluster, a gathering of several hundred galaxies located some 500 million light-years away from our own Milky Way. This distant cluster, also known by its more formal designation, Abell 2151, provides astronomers with a unique laboratory for studying the forces that shape the universe on the grandest of scales. The Hercules cluster is a dynamic and ever-changing environment. Within its bustling borders, galaxies of all shapes and sizes whirl about in a complex gravitational ballet. Stars are born, live out their lives, and die in spectacular supernovae explosions, seeding the intergalactic space with the raw materials for future generations of stars. And at the very heart of this cosmic metropolis lies a mystery that has captivated astronomers for decades: the presence of dark matter, an invisible substance that may hold the key to understanding the ultimate fate of the universe. Imagine trying to find a single grain of sand on a vast beach. That's the challenge astronomers faced when they first began to map the universe beyond our Milky Way galaxy. The Hercules cluster, like countless other celestial objects, is incredibly distant. It's so far away that its light takes over 500 million years to reach us, meaning we see it as it existed when dinosaurs still roamed the Earth. To pinpoint the location of such distant objects, astronomers rely on a cosmic coordinate system similar to the latitude and longitude lines we use to navigate on Earth. By measuring the position of the Hercules cluster in the sky, astronomers have determined that it lies within the constellation of Hercules, hence its name. But locating the Hercules cluster is just the first step. Understanding its true nature requires peering deep into the universe, using powerful telescopes to collect the faint light emitted by its constituent galaxies. By analyzing this light, astronomers can determine the cluster's distance, its composition, and the motions of the galaxies within it. The discovery of the Hercules cluster is a testament to the ingenuity and perseverance of generations of astronomers. In the early 20th century, long before the advent of modern space telescopes, astronomers relied on photographic plates and painstaking observations to study the night sky. It was during this era, in 1932, that the American astronomer Harlow Shapley first noted the presence of a faint grouping of galaxies in the constellation of Hercules. However, it was not until the 1950s, with the development of more powerful telescopes and the creation of systematic galaxy surveys, that the true nature of the Hercules cluster began to emerge. Astronomers realized that Shapley's faint grouping was not merely a chance alignment of stars, but a massive collection of galaxies bound together by gravity. Over the ensuing decades, the Hercules cluster has become a favorite target for astronomers seeking to understand the formation and evolution of large-scale cosmic structures. From the early observations that revealed its existence to the latest high-resolution images captured by space-based observatories, the Hercules cluster continues to offer new insights into the workings of the universe. The Hercules cluster is more than just a random collection of galaxies. It is a complex and dynamic structure, a microcosm of the universe itself. At its heart lies a dense core, where hundreds of galaxies, many of them giant elliptical galaxies, swarm around each other in a chaotic gravitational dance. Further out from the core, the cluster's gravitational pull weakens, and the density of galaxies decreases. Here, in the cluster's outskirts, we find a more diverse population of galaxies, including spiral galaxies like our own Milky Way, and irregular galaxies with their distinctive distorted shapes. But the Hercules cluster is not an isolated island in the vast ocean of space. It is connected to other clusters and superclusters of galaxies by vast filaments of dark matter and galaxies, forming a cosmic web that stretches across the observable universe. These filaments act as cosmic highways, channeling galaxies toward the dense nodes of the web, where they cluster together under the relentless pull of gravity.